Welcome to this session, which is the last one before, I think, the awards and the lunch break. So thank you so much for being here today. My name is Delphine Largeteau. I'm a Sustainability Consulting Director for Schneider Electric. I joined Schneider Electric about 3 years ago, and I come with a 20-plus years experience in the oil and gas industry, mainly focusing on refining and petrochemical. And today we are very pleased, Hendrik and I, to present to you how technology, combined technology, can accelerate plastic circularity. But Hendrik, first introduce yourself, if you don't mind.
Yeah, welcome everyone. Thanks for participating. Hendrik Rush, I work for Evonik, and the working title is Vice President, Circular Packaging and Plastics Recycling, but in short, I'm heading the Circular Economy program. Looking forward to a good presentation and questions later on. So back to Delphine.
Yeah, thank you. So we do have the Slido going on, and what we'll try to do is have a around 20-minute presentation, and then we'll open up for Q&A session. So don't hesitate to use a Slido to post your questions. Yeah, if I want to. Okay, so again, what we're going to show you today is how some technology like open automation and advanced additives, when you put them together in collaboration, you have synergies, and that can really accelerate the plastic circularity, and to present you a new blueprint for circular plastics. So we'll be talking about this specific project that Schneider and Evonik have embarked on. But before doing this, I just want to really set the scene again in the context. I know most of you know how complex the plastic loop is to close that loop, whether it's a mechanical recycling or the chemical recycling. That will be absolutely necessary to also complement the mechanical recycling. We know some of the challenges. For example, building that reverse value chain, that a new ecosystem has to be developed with innovative business models, new business models, and breaking those silos that we see in the value chain for better traceability. The second is dependence on regulation. We've talked a lot about these 2 days about also regulation. Yes, there are some regulation coming up, like the PPWR, but the clarity and speed to accelerate plastic circularity is absolutely key, as well as providing a playing field that is even across some of the regions as well. The third one is what we see also in the industry as Schneider Electric is how to de-risk projects, whether it's at the CapEx level or throughout the life of your plant, and how maybe how you were going to scale up some new technology and how we can help de-risk that aspect on scaling up and then scaling out new technologies. So, for example, modularization is a key component there to help de-risk those projects and optimizing the CapEx as well. But of course, it's not enough in those projects, in those journey. The securing the feedstock is absolutely crucial to make those projects fly, as well as securing the off-takers. And as Schneider, we also, as a brand owner, we also is an off-taker, and we understand the whole ecosystem as well in that respect. And the last pillar, which is very also important, is how we can advance collaboration. There was a discussion earlier in the session about collaboration. Now we're going to be talking a bit more about collaboration between different technologies and how putting them together will really accelerate the circularity. But I also want to say there's a window of opportunity right now. We see all these challenges, but you also we live in a very complex and uncertain world, as you all know, with the geopolitical uncertainty and the crisis that we are seeing now. And I think really there's a window of opportunity for resilience, and how we can become also less dependent on oil, build those reverse value chain that will help us build resilient and strong value chains. So the circularity, I think, is at the forefront of that. So it's very important that we take that opportunity right now in terms of this crisis to accelerate and to build those necessary value chain to create that resilience. So before we're going to jump into the project, we just want to also frame the stage in terms of what the companies are. So I'll start with Schneider Electric, and Hendrik will go over Evonik. So Schneider Electric is really an energy technology company providing solutions for electrical, automation, and digital solutions, and across the globe. So last year we reached 40 billion euro revenues, and we have more than 160,000 employees over 100 countries. And we like to say that we are the most local of the global companies. We are everywhere, and we're very split evenly between different geographies. And the other thing that we also are very proud of is the sustainability, because it has been at the heart of what Schneider Electric has been doing for the last 20 years, before a lot of people were talking about it. And we've embedded that into our strategy. So we've invested in energy technology to decarbonize, for example, the scaling, the electrification, also providing solutions for energy efficiency. But we've also done that for our own manufacturing plants and our own ecosystem within Schneider. So the impact here is 862 million tons of CO2 emissions saved and avoided for our customers, and 82% reduction in CO2 emissions in scope 1 and 2 between 2021 and 2025. And then we also look at that in the holistic way, in the sense that we also look at sustainability across our ecosystem. So this is why on the right we're mobilizing also our suppliers, and we have this zero carbon project where we embark our top 1,000 suppliers into that journey also of decarbonization. So they are reducing their scope 1 and 2 emissions, which is obviously a good thing also for scope 3 for Schneider Electric. So we've managed to reduce by suppliers reduced by 56% CO2 emissions between 2021 and 2025 as well. And now let's go over how the collaboration with Evonik has been framed. So Hendrik?
Thanks, Delphine. Yeah, collaboration only goes so far, from light green to deep purple. The corporate communications wouldn't agree on a mixture. For those of you who don't know Evonik, Evonik is a specialty chemicals company. And what that means is that when you showered in the morning, you slept on a mattress, you came with an EV car, a taxi here, there is Evonik inside, but it's usually not the final product. It is in there as an additive and really giving the product their final characteristics, mechanical properties, you want to call it. Just an array of what we're doing. We deliver to all the major industries. We're very proud of a biosurfactant that we just launched for the detergents market. It's also biodegradable, so addressing the biocircle. In battery systems, we have crucial materials to allow for fast charging or more mileage of an EV car. You're going to learn about the additives in the plastics recycling industry, but in a nutshell, it's making the processes more efficient and helping with the output, so making the quality of the recyclate to a higher level. During Corona, some might have heard about Evonik being part of crucial supply chains because of the lipid technology that is used for mRNA medicines and vaccinations, obviously, and then also another example of our membrane solutions, which is important for biogas cleanup, so separating hydrogen, methane, nitrogen. It's also an expertise that we have. The role of a chemical company in circular economy is usually the role of an enabler. So we bring solutions that make processes more efficient, or they clean something up, or we might even be able to solve a recycling problem of polyurethane, for example. But we're usually not the one who operates the recycling process. It's also difficult for a chemical company to talk to a brand owner directly because they don't speak chemistry. Yeah, so I think for those of you who've learned about the Aldi, it's something of a recycling dilemma, you're going to call it. Yeah, so you need the brand owner to be engaged on the one hand. On the other hand, he needs the value chain to deliver, and that needs to be orchestrated. And because as Evonik delivers to so many different industries, we speak the language of, let's say, the different value chain players. And it's very important for us to make this circular economy come to fruition, that we engage with the whole value chain. So what we founded is a circular economy program like 5 years back, like most companies, understanding that Brussels is moving towards recycled content targets very easily. So what does that mean for your own business? Is it chance, opportunity, or is it risk? Usually both. But by all those solutions that we have in our core businesses, it became clear to us that those can be applicable to other industries. So if you're already in the oil and gas industry, you are helping in the cleanup, why not taking that, for example, to pyrolysis oil? Yeah? Or taking some of the technologies you have to mechanical recycling. So that is what the project is, or the program is focusing on. So taking those core competencies, even RD&I, venture capital, bringing it to the value chain and orchestrating those newly formed circular economies. One example is circular packaging and plastics recycling, which I'm heading, heavily driven by regulation. Another example is aerospace and defense, more a geopolitical reprioritization, I would call it. So let's have a deep dive on the mechanical recycling itself. You see a simplified process from recycling to compounding. And as I said, Evonik is inside. So if you think about the flakes in the beginning, they need to be washed. You want to have a sink float separation mechanism. It's not automatically just a, let's say, washing process. If you think about flakes having adhesion, so micro air bubbles attached to it, you cannot really steer the sink float in the desired property, so you would use something like a wetting agent to make sure that the separation works. If you think about packaging, it's labels, it's inks, it's different layers that this packaging is composed of. So you want to make sure that it's fully, let's say, delaminated. You want to make sure that the labels go off. So we have additives that approach and address this specific issue, yeah? Making the quality of the recyclate higher. This is the wet stage. So you're washing. So at the end, you want to dry it up. And the less water you have, the less energy you're going to use to come to the dry stage. So we also have de-wetting agents, making sure that you have less energy. Yeah? I think you need to keep that in mind. If say less energy, at the end of the day, you want to understand what is the impact for either the one who's operating it or for the final product. So coming out of the recycling process, you can now already have a granular, a pellet you can sell, but you can also now formulate. And some recyclers have the capability to compound, so to also address maybe malodor. If you think about what's in a feed, and maybe the decomposition of nitrocellulose that will lead to malodor, you can make sure that you address certain components. Not masking it, but we can actually chemically bound some of those malodors. You want to make sure that the melt flow is in a specific characterization. You can address that already in the compounding stage. And if you have, for example, polyethylene and polypropylene, they don't go too well together, I would say. There's compatibilizers making sure that you can steer some of the mechanical properties in a way that you want it. As I said, this is a simplified process, and usually this is own machines. They don't talk to each other. So if you really now want to understand what the effect is, you know it maybe on a singular level, and keep in mind the additives are small dosage of the final product with a big effect. So being able to fully communicate what this effect means in maintenance, in energy saved, is the trigger of the project with Schneider. So making sure that those processes are digitalized and you are able to understand later on with enough data how some additive in the beginning will, what effect it will have on the end product is something that we are aiming for. And yeah, the collaboration with Schneider has the topic or the target to unlock the full potential of our additives, not only on the not only on the level they work, but also to understand on how to better communicate the effect overall. And with that, back to Delphine.
Yep. Thank you so much, Hendrik. And this is, I think you put it very well in the sense of how those machines were not necessarily communicating together, and also how, I think one of the problem statement from Evonik was also how to really drive more insight and have more quantitative value to give, performance value to give to their client. And this is what we've worked with them into defining this open automation software digital solution, really to, as enablers, to evaluate first, identify and quantify and optimize the additives. So first of all, if you remember this chain on the mechanical recycling, you see some different machines. So the first step is really to connect all these machines on a digital layer to connect all this equipment, all this device in a single digital platform. That's the first step. The second one is then to make sure that you get all the right data in real time and to to be able to contextualize and really give the proper information that Evonik wants to see. The third one is have a proper reporting and then a dashboard with some KPI that are defined alongside with Evonik. And the fourth steps is really to go beyond that and look at all the data analytics, all the information that you can derive from this data to better build some new models for additives, for example, or to cut down on some time for experimentation. For example, in the extruder, there are some lab testing that are currently necessary each time you have a sample. And you can think about AI helping you really that in the sense that you, with some of the different components that you will, the data you will get from the extruder, you will be probably able to derive a model that will cut down all those lab testing in the future. So this is really what Evonik liked about this, and to see that they will be translated in long-term outcomes, positive outcome for Evonik. The reduced number of experiments when they have to do some testing, as well as developing new additives. Again, the quantification of the impact of their additives in the recycle line. And obviously optimization on the time to market for new additive development. And now with this platform that I will just be talking a little bit more after that, is the beauty of that is that once you've designed it once, you can really easily replicate that into different environment, and the scalability is done, can be done from pilot to all the way to commercial units. And the last aspect is the energy efficiency as well. That can be driven by access of all this data. So we've used for that our solution EcoStruxure automation expert, which is really providing the digital backbone of this recycling facility, but it could be also translated into other other industries or even the chemical recycling as well. And the first pillar, which is very important, is hardware independence. You see here, we started from an existing asset, right, an existing process line, and we were able to connect this digital platform on top of it. So it's really the hardware independence which is absolutely key here. You don't need to be locked in your automation and digital with some hardware. The second one is a distributed intelligence. So again, we say that most in the mechanical recycling, most machines are not connected together. Here, with this system, we are actually able to connect the mind and how those different machines will operate together and be optimized together. So it could be also a smaller application, but a larger application. The third pillar is application-centric. So once you've developed the application once, you can deploy it across multiple assets very easily. Let's say here we're talking about this extruder and this process line, but imagine you have a full commercial size plant and you have several extruders lines and you have several machine lines. But once we've developed the code on this digital application, you can replicate that very, very easily for the others. So that's, the scalability here is absolutely key. And the last one is a digital continuity. Again, we touched on that a little bit earlier, is how once you have access to all this data, the way, because it's software defined, so you're coding already in the software layer, so it's very more intuitively and seamless connected to some of the IT tools that you can plug in into after, which is like AI that we mentioned, but also data analytics as well. And that will make your decision making a lot faster as well. So just to go back, is just to put the pieces of the puzzle together, the Evonik with the process expertise and expertise in additives, their technology, with our technology, how this is going, this is working together. On the right, this is kind of a structure, the architecture of what we've proposed for this plant facility testing. And also to add that we have a native connection with the Aviva, also software. So there's a lot of things that come in addition to that open automation software linked to the Aviva for the historical of the data, for the visuals as well. And that provides additional automation functionality and connectivity for the existing plant in Evonik. And lastly, this is just a representation of the current dashboard. And what is important to see is that we can collect a number of different data points, information, which can be also related to the power usage. So that was also something very interesting in terms of efficiency for the plant. And we think that's the beginning of a journey, of a longer collaboration, but you see how we can really collaborate with different technology together, and that makes really a strong impact on the sustainable and plastic circularity. Thank you. I think we are done with the presentation. We'll be very happy to take any question that you have. So I'll check to see if we do have some questions. So remember the Slido. Yeah, it looks like we have questions here. Or maybe let me check on the tablet. But we also can take some questions from the audience directly. If you have any questions. I don't know if it's, I think that's, are we supposed to see the questions here? Yeah.
We explained it very well, so.
Yeah. Any questions? Anyone? Okay. Has anyone posted a question on Slido that's not showing here, or not? Okay. Okay, one here. The example share is used in an Evonik facility. You want to take that, Andrew, or I can take it?
Yeah, so the facility itself is in Essen, Germany, where the applied technology is currently running. And it will be for the compounding part of it. What we're explaining here is not a finished product, but it's the scope, and we agreed on what will happen. But it will be on an existing asset that we use for testing, for all the compounding steps. Yeah, hope that answers the question.
Yeah, and I think we were doing the design, the study. The implementation is going to be online very shortly now. Yep. All right, any other questions?
Yeah, I've got a question.
Sure. Yeah.
Verbally. What is the scope of this technology in terms of the value chain? I understand that Schneider and Evonik are part of it, but what about companies that you deal with?
Yeah.
What kind of companies?
That's a very good question. In the beginning, I elaborated on this recycling dilemma. So if you think about circular solutions, they might come at some additional cost. I think there's also the rationale that everything has to be more expensive. In my point of view, at scale, things will change. However, if someone in the value chain has to pay a higher price, but there is a big benefit for the brand owner, so how do you bring them together to communicate this effect? That somebody is having a less energy consumption, if he can increase the quality to a certain standard. That will motivate a brand owner to say, okay, let's work on this, and you need data, not only the chemical formulation on how to do it, to support this statement. So the data is really needed on that end. Another point that was explained is if you change formulations, and you want in the circular economy to react faster, having a data-driven approach helps you with time to market. So there's like two effects I would derive from that.
Yeah. And I would also maybe add on the technology side, from the automation side and the data and the digitalization side, what we see is that, okay, they're limited in mechanical recycling. We see that there are silos between the different equipment. But if you translate that with the chemical recycling, which is a bit further down the chain, the value chain, there is a lot of benefits if we could really combine those two worlds together. And I think the digitalization will help do that to, for example, predict, in terms of, I know the quality of the feedstock is going to vary, and in chemical recycling, you need a very stable quality feedstock. So how digitalization will actually help you drive that. And I think that's also some of the value that we want to see more in to accelerate the plastic circularity. Okay, we have another question. The question is, are you able to define how the additive generation development has improved already? I think it's
Might be a follow-up presentation next year, right?
Yeah, we hope that we can provide you all this information probably a bit in a few months, but absolutely, yes, it should improve the efficiency and the performance of the recycling.
One more question. Is there some material that Evonik have that increase melt flow, I guess, of LLDPE materials on mechanical recycling? Yes, booth K70. Yeah, so it's the team, the experts. They sit over there in black shirts, deep purple ties. Yeah, so please come by and get some insights into the technology.
And I think both of us, we have a stand also. Evonik, I think it's
K70.
K70. Schneider Electric is M65. We'll be still here for the rest of the day. And we do have some of the demo from Evonik and other also application in chemical recycling. We'll be happy to show you that. So you feel free to come and join us at either Evonik's or Schneider Electric booth.